Good afternoon, everyone. I'm Brian Hannigan, President and CEO of Holy Cross Energy, and I want to welcome you to our third in our series of Kilowatt Talks, a live stream event for you, our Holy Cross Energy members. Now, many of you are familiar with Holy Cross Energy's Brats and Kilowatt series, the in-person events that we held in many of the locations that we serve prior to the COVID-19 pandemic. With a brat on your plate and a beer at your table, it gave you a great opportunity to interact with Holy Cross members, staff, friends, and neighbors in your community. Learn more about what's going on in your electric cooperative and some of the cool new programs or activities that are underway to provide you safe, affordable, and reliable electricity. We look forward to restarting those in-person events later this fall. Keep an eye on holycross.com for the latest updates on when and where we'll come to a community near you. In the meantime, we've been holding these Kilowatt Talk events virtually to give you that same opportunity to learn about what's going on at your electric cooperative and some of the neat projects that we have underway to continue to improve our service to you. Tonight, we're going to go behind the scenes. I'm really excited. We're going to go behind the scenes of what happens in our distribution system operations center with two of our leaders. I want to introduce Bo Jones and Jeff Huber, and we'll get to them here in a little bit to tell us more about how our distribution system, our electric grid here in our area operates, how they manage that grid to keep the power flowing and the lights on, what we do during seasons like the summer where we have concerns about wildfire risk. Last week, we heard from the line worker side of the system. Tonight, we'll hear from the dispatchers and the system operations. And so I'm really excited to introduce both of you guys. Welcome to Kilowatt Talks.
Yeah, great to be here. Good to be here.
So let's start at the basics. What does system operations, or as we call it, dispatch, what do you guys do?
Let me start. I'll take that one. So really, Brian, system operations here at Holy Cross is really the 24/7 eyes and ears on the system that we operate to keep the lights on for our members. That's really at the basic level what system operations is. We have dispatchers that are monitoring our system with the advanced technology and tools that we have in place. Provides information, data, and in many instances control of our devices in the field. With respect to the fire situation that you mentioned and the increasing fire risk in our territory, we've taken the smarts of those devices, if you will, and we alter our operating mode based on the fire risk in the areas that we serve. And that mode allows us to operate our devices much more quickly, which allows for those devices to operate, which other devices on our system, which may be spark producing type devices, will not operate. So we move into this, we transition into this this mode that we call fire settings in those timeframes where we're at higher fire risk, and obviously that's more in the summertime, in the daylight hours, if you will.
So I want to get to wildfire in a moment, because obviously summer, dry, drought throughout the western states, including here in western Colorado. We're going to go into that in detail. But I want to first start with kind of what happens on a normal day. What is the role of system operations in relation to the line workers out in the field, the members who are experiencing a potential outage, who report it either through our website or they make a phone call? Talk a little bit about what the sort of blue sky role of system operations dispatch is, and then we'll talk more about fire.
On a daily basis, our dispatchers, we monitor the system, we respond to outages, we respond to customer calls about any sort of power quality issues. If we can diagnose that here locally and help the member resolve that issue, we'll step them through the things that they need to do. If it's something that we can't resolve over the phone between the dispatcher and the member, we'll go ahead and dispatch a crew or create a service order for a visit at a later time, depending upon what the situation is.
So what are the common, well, first of all, how does a member contact dispatch to get that whole process started? What typically happens?
They would call there's several ways for the member to contact us, both during normal hours and after our normal business hours. But between the hours of 7 and 4:30, they can dial the main Holy Cross number, 970-945-5491, and ask for the dispatch department. They'll be transferred down to us, and we'll listen to what their issue is. If it's a issue that the dispatchers can handle, and if it's something that we would take care of in our department, we'll proceed with steps to resolve that issue. If it's something that is a billing issue, we will, or a possibly a rebate question or an engineering question, we'll also route those questions and those calls to the appropriate people in the appropriate department.
What are the most common kinds of questions and needs that you get to deal with?
When it comes to power quality issues, a lot of my lights are blinking. Why are my lights blinking? Why are my lights on? I only have lights in half of my house. There's tools that we have that we can interrogate the meter on their house and see what their current voltage is. And then just through experience of listening to these different issues and extracting information from the member, we can typically do a pretty close diagnostics right from our operations center here, which is really cool. If we can help that member resolve those problems themselves, and their lights get on quicker, which is pretty awesome, rather than waiting for a crew to get there 45 minutes to 3-4 hours later, when they can fit that call into their schedule. So we take those kind of calls. We take calls about vegetation control. We have a tree that's hanging over our service. We'll refer those to our right-of-way maintenance department to take a look at that. We field a lot of calls that then we refer back to the engineering department. Somebody wants to upgrade a service. Somebody wants to move the location of a transformer, go from overhead to underground. We have some general information in dispatch that we typically will pass along to our members and get them directed to the right department. Billing issues, obviously, we'll get those off to the billing department.
So you want members to call in if they've got a concern, if something doesn't seem right with their service, or they want something to be done. You want them to call in and let you know what's going on, so that you can troubleshoot it or refer it to others as need be to solve the problem. Right?
Yeah, I mean, the members own us, you own us, and we're here to answer your questions and to serve you.
Okay, so Jeff, you said something about dispatching the line crews. Last week we talked with Cody O'Neill and Rick Arnold about how the line crews interact and operate in the field in order to restore service. How do you in dispatch, behind the scenes, as we said earlier, how do you work with the folks that are in the field, and what's that relationship take the form of?
I think we need to back up a little bit too, and depending upon the nature of the call that we're receiving and the reason that we would need to dispatch a crew would dictate how we respond to that particular situation. A dig up where you have a live wire obviously requires a immediate response, and we would contact a crew in the area. We have some software that shows us where our crews are located with AVL and some satellite locating capabilities. Call those crews up and say, hey, this is the situation that's been reported to us, whether that came directly from a member, whether that came from Colorado 811 that's reporting a dig up damage. whether it's coming from law enforcement or just a passerby that saw something.
Yeah.
Depending upon the nature of the call will, like I said, dictate the response from within dispatch and whether or not that's something that we determine. Is it something that we need to respond to immediately? Is it something that we need to respond to in the next 2 hours, by the end of the day, by the next couple of days, or is this something that we just need to swing by, take a look at it, and it's probably not an issue?
So let's say that they're like, hey, my power is out. Either they're reporting it via our website, they're calling in, the meters themselves are out of power, and you see that. And Bo, I want to get to how you see that in a minute. But we know there's an outage. We've got crews that are out there. The outage is reported. What happens next?
The dispatchers will start to confirm the information that's coming in through these different
And how do they do
that? We would interrogate meters, actually call the meter itself and ask it if it has power or not.
Okay.
We look at our OMS system, and that predicts the outages. It will actually show that member geographically on the map where they're out. And then we'll look at all of the circuitry and make sure that the information that's coming in through our software matches what we would use some of our other tools, our mapping and our circuit maps and things like that.
Okay.
At that point, we would then determine where we predict the source of power would be disrupted from.
So wherever whatever the source of the problem is, here's where the fault is. Here's where we think the issues, where things start to go abnormal.
The blown fuse.
Right.
We're going to send them to either the open breaker, the blown fuse, and start there. From there, you kind of start leapfrogging in the system to restore power step by step by step by step until you either visually can find that fault or until you possibly would close into that fault with a device, and that would open that fuse back.
Yeah, okay. And then the relationship with the crews, let's say you've isolated the fault, you know kind of where you think it's going to be, and obviously you've got a role behind the scenes, they're out in the field. What's that coordination entail?
Getting them good locations as to where that fault is. Looking up some historical information through our dispatch logs for that particular circuit, for those pieces of equipment that they're going to be dealing with. Giving them some, as they're responding and traveling to that location, we're developing plans to reroute power to the members that are out once that fault is found. Sometimes we can pinpoint where the fault is at from right here in the dispatch center. Other times it's going to take the lineman. We think that it's here. It's given us some values that are already plotted on maps, and we can kind of estimate where it's at. We need them to confirm it, isolate it, and then we've developed a plan to restore power from alternate sources.
So you can switch things around from here in the control room.
Yeah.
Okay, that's pretty neat. And of course, you're coordinating with the folks in the field. You're on the radios. You're looking at here, looking at there, and so there's almost a choreographed interaction between the two teams. The one we talked with last week and the one we're talking with tonight. It's great stuff. So, Bo, I want to ask you. Jeff's describing a process where you've got a lot of visibility into what's going on the system. How do we get all that information? How does that feed back into the situational awareness that folks in our operations center can see? What kinds of devices, what kind of data, how does the so-called operations technology play into all of this?
Yeah, that's a great question. We have a lot of different type of devices out there in the field. I mean, we've been deploying devices for years, obviously. The technology has continued to improve over the years. So what we've got in place is really a communication network that those devices can bring information back to the control center, provide the dispatcher with that situational awareness, that information that allows us to work with those field folks, because it really is a teamwork effort, if you will. There's an abundance of information coming from those devices that we have access to in here. We utilize that to communicate with the field folks, and they're the boots on the ground at the end of the day, so they need to make the call when it's time. But there's a lot of information that comes in, and we continue to expand and deploy more devices so that we're covering our equipment out there even further.
Got it. Thanks. And some examples actually on the screen behind us, right? Whether it's where our vehicles are located, what the weather's looking like, what the flow on the system is, and what's open and what's not. So it's really, you're trying to synthesize all of these data streams and to figure out what's going on out there in a way that you can relay into the field to help keep our guys safe, but also help get the lights on as soon as possible. That's great. So that's normal operations. Now let's talk about wildfire. And I want to start with, we get into a stage 1 or a stage 2 fire alert where there's a risk of sparks starting fires. We want to be a little bit more careful. How does this normal operations change as we go into what we call a red flag warning or some heightened fire sensitivity condition? Can you guys describe that for us?
So we have a fire response plan. When we go into different fire stages and different warnings, like a red flag warning, will dictate and basically force us to go into a more sensitive setting in our protection scheme on our system, which means that the entire system is going to be a lot more sensitive, closer to the source or the substation when there is an event on the distribution system. What that boils down to is if we do have an event, it's going to be larger and it's going to be more frequent. And the reason that we're doing that is that we want the devices that we've deployed those short circuits, basically, without creating a spark, saving the other more traditional fuses that basically blow up. It sounds like a shotgun blast when these go off, and they have fire and molten pieces of metal that fly out the bottom of them as that fuse link blows. We're not, when we're in red flag warnings and fire restrictions and heightened fire risk, we don't want those sparks to occur out in the system, which may ignite the vegetation underneath the power lines and start a fire. So taking it back to those devices that are not going to produce sparks is our main focus, but that also makes the system a lot more susceptible to outages.
And we still have devices on our system that produce those sparks. We still have sources of electricity that come loose and create. Can we do anything to reduce those? I mean, why do we have those old fuses out there producing sparks when we know we got more fire risk?
Yeah, that's a good question as well. The traditional protection coordination has always included fuses. It just goes way back. You're trying to minimize the impact to the members at the end of the day. One of the things we have started transitioning to is a non-expulsion type fuse. We're using those in those higher fire risk areas where we don't have other options as far as a traditional type fuse. So we've started to deploy those in areas. We're probably going to continue to do that further throughout the system. So that's one area where we're.
So, let me interrupt you because I'm sure there are some members out there that are wondering, why do we even have fuses at all? What's the purpose? What do they do?
Yeah, it comes down to reliability and resiliency, trying to keep the lights on essentially.
Okay.
And protection of equipment. You're going to have equipment fail. You're going to have trees fall into the line. You don't want those type of events to affect a larger number of members than they need.
Because when a device fails, it creates some current that is not normal, and that current travels through and could potentially mess other stuff up.
Yep, exactly.
Gotcha.
Yep.
Okay, great. So we talked about fuses, but you also spoke about smart devices, which is kind of this generic class. What are the other kinds of devices that we find out there on our system? And frankly, how would members know if they're looking at one of these things? What do they look like?
Yeah, so one of the main pieces of equipment that we utilize is a recloser.
Okay.
We have them throughout our system. Those are the devices where we have the control capability and the protection settings established so that we can go to this fire setting mode. Yeah, you can see them out in the field. We have them on our overhead system. We also have them on our underground system. Provides a great reliability asset to us. We also have a lot of other devices. We're continually looking for devices that'll help us from a reliability standpoint, from a wildfire mitigation standpoint, from a resiliency standpoint. So there's devices out there, trip savers and other things that we're utilizing that again kind of go back to the simple overcurrent protection type system that we operate at the distribution level. Yeah. Just how can we do it smarter? And so those are the things we're looking at.
So how do I know if I'm looking at a recloser when I'm looking at a pole? What does it look like?
It's a square box for the most part.
Okay.
Especially if it's a three-phase device, which is what we typically have, and then also we've got a single unit type recloser as well in the system. So
now, if I'm located in an area, let's say I walk outside and I see one of these on my pole, should I assume that I'm going to have more reliable power as a result?
I'm not sure that would be an accurate assumption. I mean, what we have done from a deployment standpoint on these is try to spread them throughout the system. Okay, that makes the most sense from an operational standpoint. So may or may not be a good assumption, I guess.
Okay. All right. And how do you control these things from inside the system operations? Is it, tell the guys in the field to go make a manual change? Can you control them, remote action settings on the system?
Yeah. So the system we have in place will allow us to pretty much do everything you just said.
Okay.
Just depending on how we want to utilize it. So we've got a communication network in place that allows us from the control center to change all of the devices, not only from a fire setting that we're talking about, but also from a safety standpoint. Okay. Because we've got different settings for these devices based on whether our linemen are working near the line or they need to have a different level of protection on there. We can do that at the touch of a button in the control center per device. From a fire setting standpoint, we can do it per valley. So we've got things built, technology again, that is in place to allow us to do that per valley from here. We can also do it at the control in the field by pushing a button, if we need to.
And so fire settings are one of those control modes. What are some of the other ones that you use?
We would use a non-reclose type of setting. Typically, these smart devices are set up to sense an event on the system, a fault, short circuit. When that fault and short circuit reaches the parameters that are programmed into this device, that device is programmed to open up interrupting power to the system.
Physically open up.
Well, it's opened up under a vacuum inside. So if it had a physical opening like a traditional switch, something that you would see like in an old Frankenstein movie where you pull that handle down and the sparks go everywhere, that's what we're trying to avoid. So these devices actually have a vacuum tube inside of them, and that arc from the turning the power off is interrupted inside that vacuum tube, which eliminates the spark. So when of whatever it's supposed to operate at, that device will actually interrupt the flow of power under vacuum, not sparking, and allow it to stay open for a few seconds. It's going to prevent the fuses that are downstream of that device, it's going to prevent them from blowing.
Okay.
And that's a fuse saving philosophy that we use in our protection. That device is then going to reclose, so it's now done what we call a trip and reclose, restoring power to the entire system. It's going to monitor the system to see if that short circuit, that fault is still there. If that short circuit or fault is still there, the next protection setting that we have built into that is to, in a normal operating scenario, would be then to have the fuse blow off of isolating that smaller portion of the system before the device would open back up.
Right.
So therefore, we tried to keep everybody on, and then we said everybody's not going to stay on, but we're only going to take the power out to only the people that would be affected by that fault.
Got it.
If that fault isn't on a fused protected tap, meters call in, tell us that they're out of power. These devices also feed us information as to the intensity of that fault. And we can take that magnitude of the fault and actually plot it geographically on a map and pinpoint it down to a device or a pole that then we can give to the lineman, which increases the efficiency of getting our crews there and finding where that fault
they go right to
They
it,
go
and
right
they
to
start
it.
looking around and
Yeah.
figure out what the root cause is. And that temporary sort of opening and reclosing, the trip and reclose, that might happen in an instance where a tree falls into a line, but then it kind of bounces off the line and falls down, so the line kind of goes back to normal.
Correct.
And then that way you wouldn't have an issue because now the tree's on the ground.
Yep.
Close it in once and everything's fine. But if a tree falls and lands on that line, that's where you're going to have more of the sustained 1, 2, 3. Okay, now we got a real problem. We got to roll the truck.
Correct.
Okay, cool.
Yep.
And so if I'm a Holy Cross member and I'm experiencing an outage, do I always have to call in report the outage, or are there other ways that I can figure out what's going on?
The AMI meters that we have, when more meters call in from the same source, our outage management system will actually predict it from a meter to the transformer.
Mm-hmm.
If meters are calling in from numerous transformers, that program will automatically predict it back to either the fuse or the next protected device. If it's beyond that protected device, it just keeps working its way back all the way until it gets to the substation, to where it's finding meters that are not calling out, and that's how it predicts where we should send the lineman, where the power has been interrupted.
And then your dispatchers, your operators are looking at that, and you're using your expertise and your judgment to validate that, and then conveying that information out to the field, back to the point where you can send folks in. That's great. So, so I have an outage in my facility. My neighbors are out. I want to know how big of an outage it is. Is there a place that I can go to look and see where the outages are on our system at this point?
The best place to go right now would be the holycross.com and look at our outage.
Okay.
When these outages are reported in through our outage management system, the dispatchers it takes us some time to process and to confirm that information that's coming in from these devices is actually correct.
Yeah.
At that point, that outage is verified, which then would plot it onto the map. With that, as we get more information coming in, sometimes the dispatchers don't have any information.
Right.
And we can only put out the information that's there. We don't want to put out any erroneous information. And it does take us some time to put all of that together and get it into what we would call our dispatch comments section of our outage management system. Then that would automatically be plotted onto that outage map, telling you the size of the outage, how many people are out in the general area. If we get a response back from the line crews, we think this is going to take 4 hours to fix, then we can put that estimated time of restoration in there. If we don't get that information back from the field, we leave those fields blank because we don't want to give out information that's not accurate.
Yeah.
Same thing with the cause. We can put causes in there, whether it's an animal cause, whether it's a pole failure or a conductor failure. If we don't know what the cause is, we'll just leave those blank. So as we get more information into the dispatch center, the more information will go out
onto the map. And if I'm a member, is the map the only way I can find out where the outage is, how much it is, when it'll be restored, you think?
Certain members that have opted to have text and smart, if they have a Smart Hub account, they can go in and there's several options for them to be notified. So I would highly suggest that most of our members go in and set up a Smart Hub account and look through that and figure out how they can help us help them, with providing them information.
So they could actually get a notification like text or email or something that says, hey, we've detected an outage in your area, here's what's going on, and kind of saves them the hassle of calling in and saying, yeah, there's an outage, yeah, we already know, thanks very much. So that's kind of a cool feature.
Unfortunately, during the outage itself, it's the dispatchers are really busy crunching all of these numbers and processing all this information, and it's very difficult for them to respond to all of the telephone calls. So as technology gets better and we get better at providing that type of information via text, via the outage map and those types of things, that's a goal that we have in system operations, is better member outreach and response.
So how do you know, A, what caused it, and B, how long it's going to take to fix when there's an outage or an interruption on the system? How do you get that information?
That information in the operations center wouldn't be known until you actually have a line crew go out there and respond to it. Or we have information that's coming in from a first responder, fire, police, possibly from Colorado 811. The excavator is dug through a line somewhere. They saw sparks. They have identified a facility that resembles a Holy Cross facility, and that particular geographic area lines up with the outage. That's an assumption. To verify what the cause is really takes us getting our crews out there and getting some eyes on it. So that's the delay a lot of times in getting information back to our members.
But I want to pull on this a little bit. Is it fair to say that a smaller outage is going to be restored quicker than a larger outage? Can you correlate the size and the number of meters in the system affected to the duration, the 1 hour versus the 4 hour? Or is there more to it than that?
There's more to it than that. A smaller outage may be a pole rotted off and fell over, and that pole is in an area that's not accessible by heavy equipment. So therefore, the responding crew has to dig a 6 to 8 foot hole by hand and carry a pole in by hand and set that up. Even though it's only affecting 2, 3, 4, 10 meters, it might take a while.
Yeah.
As opposed to a entire circuit that blocks out, and it might be in close proximity to where a crew is at, and the cause is easily identified as, say, a bird dropped a limb across 2 wires and it caused a short circuit and made that device open up and interrupt power. There's some problem areas in our system due to some bird activity that we typically know that, it's going to be that bird again. And so our crews can get out there right away, clear that limb off, or that, fix that situation and restore power. So larger outages or smaller outages, it really comes down to what was the cause and how much damage occurred during that particular event. It really dictates how long it's going to take to restore.
So, Jeff, you've been here both as a line worker and now as a manager, system ops for a long time. You've had a lot of experience with a lot of outages. You talked about there are a number of causes. Bo, you were working in Kansas before you came here a few years back. You've seen a lot on the utility system as well. Why do these outages happen? Like, what are the most common causes that you see? There's got to be a bunch.
Yeah, I would put them into just a few categories. Weather, equipment failure, trees, and what's the fourth one?
Critters.
Critters. Yeah. So typically you're going to fall into those. There are on occasion some unknowns or oddball things that occur, but for the most part, it's going to fall into those categories. That's why we operate the system the way we do in anticipation of those kind of things when it comes to weather in particular.
Yeah.
That's a big one.
And as you look ahead over the next couple of years, let's take those four categories. Weather, more or less likely. Trees, more or less likely. Equipment failures, more or less likely. Critters, more or less likely. What do you think?
I think it's going up,
unfortunately.
Yeah.
And what are some of the things that we're going to be doing as we look ahead to the future around technology, processes? How do we counteract those trends? The threats going up, how do we respond to that better? What are some of the things that we're doing around new technology?
Yeah, one of the things here at Holy Cross is we're definitely really on the cutting edge in a lot of areas when it comes to new technology and at least evaluating new technology. And I would say from a system operations standpoint and from a protection standpoint, that's certainly the case. So we're always looking for new ways to utilize the devices that we have and the control capability of those devices to do things a little differently, to improve the way we operate those devices, to address things you just mentioned in the ways that we can. In addition to that, there's a lot of focus from a manufacturer and a vendor standpoint on wildfire risk mitigation, things of that nature. So there's new products coming out. We're in constant contact with those manufacturers and vendors to evaluate whether it makes sense for Holy Cross to go down a path. We do a few pilots here and there to try to test things out. So those are the big areas that I see as looking at.
One of these things that we do in system operations is through our outage management system. We also track the frequency of outages on particular segments of our system, which will then identify areas that we maybe need to do more maintenance in. We need to get our tree right-of-way clearance crews out there to maybe take a look at the lines to see if some of these outages are being caused by trees. I think Rick and Cody in the last Kilowatt talk talked about some of the things that they did with the drone inspections, and those are kind of driven by the frequency and of where these outages are more susceptible areas. And obviously, the type of system and where you're at within Holy Cross's service territory, the further out you are in these drainages, and if you're on an overhead system as opposed to an underground system, you're definitely going to be more susceptible just because of where those facilities are and how they get to your service location.
But you can still have faults and issues on underground. Right.
Definitely.
You probably don't. You may have the critters because you don't have the trees because it's underground, ideally. But you do have the equipment failures. Does weather affect underground as well?
Weather really doesn't affect the underground system as much as when you're talking about wind. Obviously, it's buried in the ground. Or snow or ice or those types of things. The things that affect the underground system is typically age, moisture. If it's an underground facility that has a lot of load on it during the winter and then becomes lightly loaded over the summer areas, just like what we have here in ski country.
Yeah.
That affects a lot of the splices. It draws in moisture, and usually in the spring when the resorts shut down and we're not making snow, we're not running lifts, that's when we experience a lot of our underground faults. They show up in the springtime.
Great.
When you would think that because you're using more that the thing would blow up, and it's actually the opposite for us.
Yeah. One of the things I learned when I got here is that our system's happiest when it's fully occupied.
Yeah.
So it tends to be quieter in the peak seasons and a little bit more creative in the shoulder months.
So one of the things that one of the other things that would affect a underground system is actually animals, snakes, marmots, squirrels. They like to get inside those electrical pieces of electrical equipment because they're warm during the winter.
Yeah.
So we do experience quite a few outages because of snakes and rodents during the winter time.
So stay out of the vaults for safety, but stay out of the vaults if you don't like snakes too, right? So I want to make sure our members know you can go online right now and put your questions into the chat. We'd love to hear what's on your mind related to operation of the system, or frankly, anything that's going on here at Holy Cross. I would be remiss if I didn't ask you one question, and that is, we know that a lot of our members are putting rooftop solar on their houses and in their communities. They're starting to employ batteries, possibly with our help through things like our Power Plus program. They're plugging in electric vehicles. They're using electricity and interacting with our system in new and different ways. What kind of challenges or even opportunities does that bring to you when you look at the standpoint of trying to operate the system with more stuff hanging off of it than it used to have? What does it mean for how we operate, what kind of skill set you need in the control room, some of the new devices and technologies that are out there? What do you think about all that?
From system operations standpoint, the operating the system with renewables on it for us really isn't an issue, especially rooftop solar. Our requirement to interconnect to our system would be if you lose AC power, your system has to shut down and shut off.
Okay.
And that's a safety issue to make sure that we're not backfeeding into our system when our line crews go out there to respond and try and fix the issue.
Right.
We don't want a source of power there.
Right.
So as for the larger solar projects, kind of the same way. For example, the biomass plant there in Gypsum actually has a fiber line that runs from the plant back to the substation on the south side of the Eagle Airport there. And when a issue is sensed anywhere on that particular circuit, it automatically drops them offline. Okay. So there's a lot of safety that's built in to our system that really helps us isolate and keep the system safe, not only for our crews, but for our members. We just want to make sure that we're isolating those sources of power when there is an issue.
Do you ever see a day where maybe those sources of power are what you use to keep the lights on locally, even as you go and fix the other portions of the system that might not be functional?
Yeah, I do, Brian. I would, just to answer your previous question more from a protection engineer standpoint, there are challenges associated with how the grid is evolving, if you will. But we're up for those challenges. We're involved in different discussion groups. We're addressing the protection concerns through the devices that we have already deployed, and then the new approaches going forward. We're always focused on reliability, so we need to make sure the lights stay on, and do that with these different devices on our system. One way we can do that is from a resiliency standpoint. Is there a way to utilize those devices, the solar, the batteries, the other things that might be coming, in such a way that we can maybe island parts of our system off, and if we have a blackout, that there's ways to bring those
kind of
pushes up our
this
system
this
up.
microgrid concept that
Yeah.
people are talking about.
Yeah.
Okay.
Yeah, exactly. Yep. Cool.
Okay, so we're coming close to the end here. I've got a couple of questions that have come in on the chat. Timely one, given the continuing closure in the Glenwood Canyon. Do the mudslide canyon closures impact Holy Cross Energy operations?
The major impact that Canyon have had on this is just the ability to travel from district to district, from the Eaglevale Valley back over here to the Roaring Fork Valley. Our facilities run through the Glenwood Canyon from the east at Dot Zero down to Hanging Lake Tunnel. The west side of Hanging Lake Tunnel is served by XL Energy. So the areas where we had the mudslides really did not affect our distribution system.
Okay.
The ability to get supplies over to that valley, or personnel, specialized personnel from one valley to the other, that's our biggest impact that it's having on us right now. And kind of the same thing when we had our fires,
Right.
the Lake Christine, recently the Sylvan Lake fire and the Grizzly Creek fire. Those events damaged a very small portion of our facility, but we were monitoring those situations constantly, in contact with emergency management agencies throughout the state on a daily basis, relaying our information as to where our infrastructure is, and developing a plan of working with those agencies to mitigate as much impact as we could on our system.
Got it. You mentioned the Sylvan Lake fire. So, so far this fire season has had relatively little impact on our operations of our system. But, Bo, looking ahead for the rest of the summer, handicap it. Are we almost out of the woods, not out of the woods? What's your thought on kind of the wildfire outlook for the rest of the summer, and what should we be thinking?
Yeah. I wish we were out of the woods, I think, because like Jeff mentioned earlier, when we take these steps to move into this different operating mode, we do have some risk associated with that, as far as member outages and the extent of those outages, as well as just the equipment that we have in the field and the possibility of damage there, and the impact of that. I don't know. It's obviously, recent rain has helped, but is that going to continue? Who knows? It doesn't seem to be trending the right way if you look at the last few years. So it's hard to say that, it's not going to maybe continue to get a little bit worse when it comes to the potential.
Yeah.
And so we'll continue to try to stay ahead of that from the processes and procedures we have in system operations to, again, operate our system in a way that doesn't limits the impact or the potential for causing a wildfire.
Do you ever see a world where we might have to do what they do in California and now Oregon with these public safety power shutoffs, where we actually proactively de-energize areas and say it's too risky to keep the power flowing?
We've had conversations around that. If you look out in California,
and we would want to find other ways to keep the energy services on for our members, whether it's in one location, maybe it's one of these microgrids. I mean, who knows?
Yeah.
But unfortunately, I think we have to start thinking about that stuff. So, question in from a viewer. Thank you for this. How do you receive power from XL, or maybe I should say the broader regional grid? We've talked so much about our distribution grid. How does that connect into this broader regional grid that 2 Kilowatt talks ago, myself and Steve Pointing spent all over talking about RTO this and transmission that? What's the nexus there?
So, yeah, I'll take a shot at that. So our distribution system is interconnected at the substation level with the transmission system.
Okay.
Our transmission operator is XL Energy. So that is really the connection to the broader grid.
Okay.
At the transmission level, that's a whole different ballgame when it comes to operation and everything else. So it's probably not worth getting into that at this point, but that substation connection point is where we interact with XL.
So it's kind of like getting off the highway and going on to the county road.
Yes,
Good. So, okay.
Yeah.
Cool.
Whereas the interstate system, you don't have stop signs, you don't have traffic, you have speed limits and things like that, but it's a larger conduit for travel. You get off into, so the electrical system kind of works the same way. Get onto the highway systems, which then becomes our distribution systems down to your rural roads and your roads to your
tap right to your home, your driveway.
To your home,
yeah.
Which kind of equates down to the transformers and each individual service.
Nice. That's a good way to think about it. Does hotter weather create more issues? We've had a heck of a summer so far. Weather's been a lot hotter than many years. Does it create more or less issues on the system?
It can create some issues with equipment heating up.
Okay.
Transformers are full of mineral oil, and electricity and the flow of electrons creates heat. That mineral oil not only insulates keeps the electricity from shorting out, but it also is a cooling agent. The hotter the weather is, the hotter that equipment is. Heat is definitely a huge enemy of anything electrical, and so it breaks down the insulation. But our equipment is built to withstand those normal heat rises that we see here. In our system, we're typically a winter peaking system, so it isn't so much the capacity of our entire distribution system that would be increased that would cause more outages. So in short, it has some minor effects.
Maybe depending on what it is and where it's at.
Yes.
Okay.
And depending upon how loaded that transformer is too, how much heat is actually created from the equipment that's connected to it.
Great. Thank you. So one of our viewers at my house
is there's not a cookie cutter answer to that.
It depends, doesn't it?
Depends. Everything depends.
Yeah, explain why that is.
Depends on where you're at.
Okay.
Depends on where our crews are at. It depends on the canyon is closed, Red Canyon is closed, 82 is closed.
Yeah.
Due to a traffic accident, due to skier traffic. Weather conditions, we want to keep our line crews safe. Everything that we do, and I think that, we kind of missed that point here early on, but everything that we do is actually for the safety of our members and the safety of our crews. That is our number one priority in anything that we do. So unfortunately, sometimes the answer is we can't get there until it's safer for our crews to get there.
Yeah.
Typically, and depending upon the type of issue that you're having, most of our residential meters that would go up to a 400 amp service actually have a switch inside of them that we can operate remotely right here out of our distribution system.
Okay.
So a lot of times when we get calls for a structural fire,
yeah,
we can go ahead and make it safe on the scene for the first responders, the firefighters, the EMTs, by actually sending a signal to that meter, opens up that switch and disconnects the power from the meter into the house. Now, obviously, the service wire from the transformer to the meter is still hot,
right?
But at least inside the structure, that's dead. So, depending upon the type of service you have, we may be able to disconnect that remotely for you.
All the more reason to call 5491 and say, "Here's my problem. Help me fix it."
Let us help you. We've probably handled just about, I don't want to say we've handled every situation that could ever come up, but it never ceases to amaze me, some of the calls that do come in, and it's like, wow, I would have never thought of that one. But for the typical type of problems that our members have, we typically have a good solution.
Yeah. Great. I bet you've seen a lot too, but that's for another time. Okay, so Bo, back to you. This is a question a little bit kind of hinting at what I was talking about earlier. What are the effects of more electric vehicles, more heat pumps for heating and cooling, more air conditioning load? How do you plan for that if you know that it's coming when you design a system, when you maybe decide what parts to fix, what parts to not fix, how does it factor into the planning of the distribution system?
Yeah, there's a whole process that we go through from a distribution planning perspective, looking at the near term and then also looking at a little longer term. We're taking into consideration all of those new devices, that new load that's coming. So when you talk about EV and changing heat pumps and things of that nature, as well as the new renewable resources on our system.
Yeah.
We have a process in place to study our system in the future.
So you try to figure out what's coming and
Yep.
how to build to accommodate that. And
Right.
It's a forecast like anything, like weather forecast.
Sure.
Right. But you do your best.
Do the best we can, and then build the system out to serve that.
Got it. Thanks. So we're going to take one last question and then we're going to wind it up tonight. Jeff, you've been talking about the beauty of all these automated systems. Member asks, why are they still out of power when your automated system is informing you that the power's been restored? Clearly somebody's not aligned there.
Yeah, the outage management system that we employ to predict outages also automatically restore the outages and the notifications that go out. And it's just part of the way that the program has been built. We've been working with NISC, that
our provider
of that software, to make that software a little bit more robust.
Yeah.
But rest assured that if you're out of power, the meter on your house is also reporting to me, even if we're telling you that your power's been restored. Here in the System Operations Center, you are plotted on a map and we know that you're out of power. It takes us a little bit of time to do that manual calculation and to re-establish an outage that would affect.
Yeah, so these are imperfect tools, and
Yes.
we're continuing to refine them. And occasionally, you're going to be on when it says you're off. You're going to be off when it says you're on.
It's the nature of what we're working with right now.
Give us a call if you have any questions, and we'll walk through that with you. Well, great. Thank you, guys. It's been a blast talking with you about the behind-the-scenes work here at our dispatch and our system operations. And I want to thank all of you, our viewers, our members, for attending this third in our series of Kilowatt Talk live stream events. We'd love to hear what you thought about this afternoon's event. So visit our Facebook page or our website at holycross.com and post a comment or review there. Continue to watch your email or visit our website for information on the date and the time of this and future Kilowatt Talk events, and also our Brats and Kilowatt series that will be starting in the fall at a brew pub near you. And make sure to invite your friends and your neighbors both to watch this online event and to come into Brats and Kilowatts when we start in your community, because we look forward to seeing you. We want to gather in ways that are safe, but that are also informative and enjoyable for both you and us. And believe you me, every time we have these conversations, I learn more than I thought I would, and it's always a great opportunity to visit with folks that are way smarter than I am. So until then, on behalf of all of us here at Holy Cross Energy, I wish you a safe and healthy rest of your summer, and I look forward to seeing you again in person very soon. Good night.